Well, we'll go ahead and get started. We've got a kind of a short presentation with the what I needed. Here, you got it. You want to go there? Go there.
Audio out. It's a louder speaker than that speaker.
You see my sign on the door?
That's good.
Should I turn the lights on so you see it?
Probably be better.
See that better?
Now you made this.
What?
You put this together.
Oh, yeah. These, this is kind of a follow-up program to what Chuck presented, and we'll probably go into more detail. Really what I want to do is, as we get into this, we'll be accumulating more material for you. I had your head deacon brought over some fencing today that you could, if you wanted to take it back and make a compost pile out of it, or you fence in your little garden, you can do that. We have been talking to several individuals about getting wood chips, and I think today, when you see the video, you'll understand why wood chips are so important for Florida soil. I mean, more important maybe than some of the other compost that you may be able to get. It takes a little longer with wood chips, but they are very, very good. Think about it this way. The trees, they reach their roots down in the soil to pull everything out that it needs to grow, to produce leaves or seeds or whatever it's producing. And when the leaves fall, we use the leaves again for compost. Today we're going to talk about that. You know, how do you equate what to put into your compost pile? Wood chips, on the other hand, are loaded with all the minerals and everything that over the years that has been growing has collected in the plant. And these are extremely important as they decompose with the bacteria, the funguses, and what have you that you have. As it decomposes, it forms a very rich compost that are loaded with these minerals. Now, I want you to remember that because we talked about C90 before, and you understand that when we talk about this, we can add certain things to the compost to really supercharge it, you know, with these additives that we can add to your compost. Now with Pastor Graham and Coretta have taken and put different things on their soil over there. Chester has too, wood chips in particular. And I've asked, you know, several people, whenever you see these guys on the street that are chipping wood on the side, tell them we have a place to put it. You put it in my house, you can take it and put it up at Chester's. How many loads can we put in there if we need them?
I thought you
Well, they are very, very good to have, and the hardwood in particular that we have here in Florida, extremely good. So what we're going to talk about today, and before we do get started, I'd like for us to have a word of prayer. Father God in heaven, thank you so much for the opportunity that we have to work in nature, to work with nature, to work with you in developing our soils, to develop good food that can nourish us, keep our brains and bodies active, and that we can help other people. And has been suggested, we pray, Father, that this is the beginning of another outreach program for our church. We ask that the Holy Spirit will bless in our efforts and guide us in our presentations and in our learning together. We thank you so much. In Jesus' name, amen. So today what I want to do is talk about building our soil. As you note in the next slide here, the typical types of soil here in Florida, if you go pretty much anywhere in the state, there are pockets of different things in the state, but they have a soil called mica, which is basically a gray sand. And it covers over 1.5 million acres here in Florida, and it is considered the official Florida soil. In our area here, we have more of a typical sand. It goes sand loam. In fact, some of this that you brought today is considered sand loam, not sugar sand that we find, say, in the groves over in Polk County and in areas like that. It's pretty much bad dirt, right? But do you realize that the sand particles are loaded with minerals? Some good, some bad, but they're loaded. All you have to do is kind of encourage it along for the microbes to come and start working on that. But what happens in our area here is we've tilled our soils, we've sprayed, we've used fertilizers, we've used things on it, and it becomes pretty much dead. So what we want to do today is talk about how to make your soils live again, even sandy soils that you have. So I'm not going to go into the other ones because we don't have them in this area. But here's how you can identify. Can you read that? You can identify, what kind of soil you might have if it's varying colors. In some areas, we've got organics and what have you in there. Just take a quart jar and you fill it with your soil. Go down about, 3 inches, and take the soil there and take about 1/3 with topsoil and then add water to it. All the way to the top, and then screw the lid on and shake vigorously. Now make sure that if you got any clumps in it, that it breaks up, If you'll notice what they do, and you just leave it sitting for a while, it begins to settle out. And you will find that most of the organics will be from the top down. If you have a silt layer in there, sand go all over the bottom, all right? The silt layer or the next layer in there, thank you. The next layer that's in there will be any kind of silt or clay. And this is good. There's nothing wrong with clay mixed in with the sand, and there's nothing wrong with organic mixed in with the sand, because it's all going to be beneficial once you start building your soils up, all right? In preparing for your garden, I was asked this, should I till my soil? Should I chop up, how many of you use a rototiller on your soil? We always have, right? That's how we chop it up so we can plant in it, right? They're saying that it's not even good to do that. But in some situations, I was looking at a little 2-acre plot. They had weeds that were 6 foot high. You're going to have to go in there and cut them down, and you got to do something to get rid of them. But you've got weeds. You got nut grass here in Florida, you got Johnson grass here in Florida, you've got all kinds of pesky weeds that'll come up. So they call the next procedure solarization. And I have a little video on it you can see. But it's simply a non-chemical technique that captures the sunlight and causes a physical, chemical, and biological change in the soil. What does that mean? Well, primarily it's going to kill your microbes. It will do that. But it begins to kill the seeds. I suggest that you get maybe a thermometer and just check it and see when you set up this solar, very easy to do, you'll see it in the video, like I said, to just check and make sure that it gets up to about 140 degrees, because if it does that, it's going to kill the weed seeds, and you're not going to be pests. I mean, they're going to come back, because some of them grow from rhizomes, and you're not going to kill all the roots, you're not going to kill all of those. But generally speaking, you will kill all the seeds and kill a lot of the weeds, and not have to use any kind of Roundup or anything like that, or keep tilling the soil all the time to get rid of it, or going out and weeding your garden. All right, it will help you to eliminate that. Over several weeks, it gets hot enough that it will kill even the pathogenic organisms. I'll tell you right now, we're going to talk about pH at the end of the program here, but we need to check your pH of your soils as well. If your pH is too acid, you find that you have the pathogenic organisms. If it gets too alkaline, you also have pathogenic organisms growing in there. So you've got to keep it as we'll state in the slide here, you've got to keep your pH about 6.5 to 6.8. That range is the best to keep from growing most plants here in Florida, unless you're growing blueberries, and then it likes acid. All right. I'm gonna see if I can get this now. It's not going to show, is it, that way?
I'm probably going to stop the PowerPoint and come back to it.
Check it.
Probably going to have to stop the PowerPoint and come back to it.
Okay.
My name is Sean Steed. I'm with the University of Florida Institute of Food and Agricultural
PowerPoint's
Science
got your
Extension
screen.
in Hillsborough
Is it?
County. Today,
All right, I took it out. It's done. It's showing it. Yeah. I'm gonna go through the videos and then go back and talk about it, okay? Then I can get back in. Back in.
my name is Sean Steed. I'm with the University of Florida Institute of Food and Agricultural Science Extension in Hillsborough County. Today we're going to talk about solarization of soil, heating of soil to recycle it back so you can reuse it. Here we've got a model of a recycling soil solarization area, and it was mainly developed for the commercial nursery industry, where they're dumping used potting soil into a big pile. And previously it was waste. Now with this method, we can recycle that soil back into production. What this is going to do is this plastic is going to trap the sun's light and turn it into heat. And it's going to raise the temperature of the soil to cook all the bad organisms in there, like fungus, bacteria, weed seeds, and it'll sterilize it to where you can reuse it. You're going to need a top sheet of plastic separated from another sheet of plastic by about 4 to 6 inches. This top sheet really retains the heat and makes the system operate more effectively. Underneath the top sheet, we have our brace to hold it up. If we remove that, you can see our bottom sheet, which is flush against the soil. Underneath this sheet, here's our potting soil that we're trying to sterilize. If you're going to try this at home, you want to wet this soil, not to soaking wet, but just damp enough to make sure it's moist. That'll make sure that the heat will move through the soil profile. Also, you don't want this soil to be too thick. And you can see I only have a few inches of soil in there. 3 inches or less is going to work the most effective. Any larger than 3 inches, it takes much longer for the heat to go down and penetrate, and you start losing the effective killing of that heat temperature. If you've got container gardens at home, or you've got old pots of soil or dead plants, instead of throwing them out and buying new soil, you can use this method to recycle that soil. What this will do is it'll sterilize all that soil with about 140 degrees temperature, and it'll kill all your pest organisms, nematodes, fungus, bacteria, weed seeds. And you can use this, you can dump your container soil in here, you can build a small area, or if you can't do it with potted soil, you can use this in your garden. This can go right over, you can lay this plastic right over your garden at home. Make sure it's wrapped and sealed at the edges into the soil. Lay something above it to keep the second sheet from touching this bottom sheet. You want an air space between these two plastics. After you do that, you want to wrap it tight, keep the edges down, and this will cook a few inches of soil, so it'll sterilize it like you've just put in new potting soil. If you leave it for a long time, you'll get a better kill on your pest organisms if you're using it in the ground. If you're using potting soil and you built something like this, say for your pots or your container soil, this will cook it within a day or two. And you can check that by using a soil thermometer. You want at least 140 degrees Fahrenheit for 1 hour to kill all those pest organisms. The longer you leave this in, the more effective it's going to be in the broader scope of pests that you'll kill. Even though this was a method developed for the nursery industry to help them save potting soil, it can be very effective for the home gardener. You can reuse those old pots and those containers of soil, or you can use the soil in your garden and make it fresh again using solarization. These two pieces of plastic and a little bit of time will save you a lot of money in buying fresh soil. If you have any further questions, you can contact us at the Hillsborough County Extension Office. Please feel free to check out our website or call our number, and you can also drop by for a consultation.
What he was talking about primarily was recycling soils, but he did mention that you can do this on your garden. This plastic that he shows there, very inexpensive stuff. You can get it anywhere. We've used the black plastic as well. Works just as well. All right.
He said what he was killing. And he said biology.
Yeah. Kill some of it.
And we're wanting to grow biology.
Yeah, but that's fine though, because you got to remember your soil. Like we were going to find today, they have a lot of pathogenics in there. They got a lot of nasties. Because what we're going to talk about now is building good soil. once this has happened. Because right now, if you're growing weeds, okay, on your property, most likely your soil lacks oxygen as well. And that's something else that the wood chips and things like that will do. Compost does this as well. Because you've got to oxygenate your soil. There are things you've got to remember. You got to have the right pH. You got to have the right oxygen in there. You've got to have the right carbon and the right nitrogen. Those are the ones that are most important to get you started, because then the microbes will come. We're going to talk about that at a future date, how to, again, we've mentioned it several times, Chuck mentioned it, that we can actually make our own microbes, inoculate our soil with those microbes. And we want to do that. A lot of you're going to find you've got a lot of them in your soil now, especially in some of this compost we're going to be looking at here. I guess, Chester, instead of me trying back and forth, I'm just going to go through the videos right now on this, okay? This is a sand soil. Look at how bad it is.
This picture gives you an idea of just how bad our soil was when we moved into our house. Grass wouldn't grow and even weeds struggled. The topsoil was a rock-hard mix of sand and clay. It cracked when it was dry, and every heavy rain flooded the yard because there was little organic matter in the soil to absorb water. We transformed this barren soil into highly productive garden soil over time, simply by adding compost, vermicompost, and mulch to the soil surface in our shallow raised beds. We also mulched our pathways with wood chips to suppress weeds and retain moisture in the soil. And what I discovered last summer is that the soil in our wood chip covered pathways is just as fertile and productive as the soil in our garden beds. Last spring, in my never-ending quest to grow more and more food, I broke out of the confines of our raised beds and planted tomatoes in pathways that had only been amended with wood chips. I didn't add compost or other amendments when I planted them, and I couldn't have been happier with the results. The plants were vigorous, healthy, and incredibly productive. They did just as well as tomatoes we grew in raised beds that had received a lot more attention over the years. Of course, the compost and vermicompost added to the beds probably improved the surrounding soil too, but nevertheless I was impressed with the results of the tomatoes grown in wood chip covered pathways. I'm now sitting in about the same spot where our cat Maya was sitting in that picture I showed you earlier. And what I thought I'd do today is dig down into this pathway to see how much the soil has changed since that picture was taken. This pathway's been covered with wood chips now every year for the last 8 years. Let's start digging and see what we find. The first thing I notice is that the soil is no longer gray. Instead, it has the dark, rich color of a soil that is rich in organic matter. With all of this organic matter, the garden soaks up water like a sponge and doesn't flood like it used to when we get heavy rains. I also notice that the soil is no longer hard, and my task of digging into it goes quickly and easily. The soil here used to be rock hard, but in no time at all I was able to dig a 16-inch hole. The only resistance I ran into was some fine tree roots. And what's remarkable is that the soil has been transformed, not just at the soil surface where the mulch was applied, but all the way down to the bottom of the hole. Let's take a closer look. The soil on top is from 16 inches down. It's dark and rich, and like good soil should, it holds together when I squeeze it, but easily crumbles apart. When I reach down to the bottom of the bucket for the soil that was removed from the surface, I find that it has the same characteristics as the soil from 16 inches down. Now let's see how deep I have to dig before I see a change in the soil characteristics. Much to my surprise, as I dug deeper and deeper, the soil maintained the same basic characteristics of being dark and rich in organic matter. It wasn't until I reached a depth of 26 inches that I started seeing less organic matter and more sand and clay. Let's take a closer look. At this depth, the soil loses its dark, rich color, has less organic matter, and has more sand and clay. I was surprised to see that the soil was transformed to a depth of 26 inches. I should reiterate, this happens simply by applying wood mulch to the soil surface over a period of 8 years. So if you think you need to till organic matter to the soil to see something like this happen, This is good evidence to the contrary. So let's get this hole filled in before I fall in. I wanted to share this with you today because people often comment on how good our soil is, but of course they don't know how far we've come and how bad the soil used to be. So by sharing this transformation, I'm hoping to encourage those of you who are struggling with poor native soil. If we can transform our soil, so can you. And I focused on the pathways instead of the raised beds because I wanted to show how much native soil can be transformed by doing something as simple as keeping it covered with wood chips. Yes, the compost and vermicompost added to the adjacent beds likely played a role as well, but I'm certain the wood chips made a huge difference. And after 8 years of mulching, the soil in our pathways is just as fertile as the soil in our raised beds. Given how well our tomatoes did last year when growing in soil and then only with wood chips, we plan to do more of the same this year. If you've used wood chips in your garden, please let me know what impact you've seen it have on your soil and on your crops. Well, that's all for now. Thank you very much for watching. And until next time, remember, you can change the world 1 yard at a time.
I don't think we'll have 8 years to wait to garden though, right? But you put wood chips on yours, right? How long ago was it that you put them?
2 years ago.
And now when you go out there, you brought some of that soil here, right? What does it look like versus what before? Can you tell us?
Well, before it was just what you see out there with the grass. And I covered the grass. I put a little bit of compost, mushroom compost down, and then I put that on about 6-8 inches. Covered the black tarp for about a year. We put a little bit of fish pond water on early on. And then last year we grew on it.
So it was 2 years before you started growing on?
Got that. And it had been composted in the pile for at least a year. Probably.
So what would you suggest? That you would go ahead and do a compost on your garden first and start growing on it and put chips on top? Or would you wait for your wood chips to degrade to grow on it?
The problem we had last year when we put potatoes in, when we grew them, there was a lot of big wood chips still in the ground. Potatoes were good. But
Funny looking.
But they were funny looking and all deformed because they were growing around the wood.
Yeah.
The cucumbers that she grew she's done them before and been trouble with pests and had one, and they grew. This year we had cucumbers coming out of our ears and virtually no pests. We tried corn and it didn't really do too good. She did okra and it did good. And some beans.
Did your beans do okay? All right. Well, what we're going to suggest is that in doing this gardening, instead of waiting 2 years, to grow in your garden, is to prepare it first, like we talked about, if you're getting rid of the weeds, weed seeds, and what have you with the plastic wrap. You might want to try a small area, just to test it out and see what happens with it there. But the next video is primarily on developing a compost. And then we'll go over it back in the slides, how, there are different ways of doing it. Make it simple, you don't have to make it real complicated. There is a formula that you should use, with this you can throw things out in a compost pile and wait 2 years to make compost. Or you can actually speed it up, and that's what you're going to see in this video.
Most people think composting is as simple as throwing all food and garden waste into a container and leaving it there for a couple of years. While you will get compost that way, you can produce much better compost and get it much more quickly if you follow these simple guidelines for the perfect recipe. There are 4 ingredients for good compost: greens, browns, air and moisture. These 4 need to be balanced correctly for best results. The ingredients you add to a compost heap contain carbon and nitrogen. The ratio of carbon to nitrogen determines whether we label it a green or a brown. Ingredients that have a relatively high nitrogen content and a carbon to nitrogen ratio below 30:1 are called greens. Ingredients with a lower nitrogen content, in other words a higher carbon to nitrogen ratio, are called browns. Colour isn't always a reliable indicator of what is a green or a brown material. For example, fresh grass clippings when spread out and left to dry are still considered a green ingredient even though they've turned a brownish colour because really all they've lost is water. On the other hand, straw is always considered a brown because before it was cut the main stems had died and much of the plant's nitrogen had gone into the seed as protein. Good examples of greens to add to your compost pile are grass clippings which haven't been sprayed with weed killer, vegetable waste, fruit peel, annual weeds before they've developed seeds, and old bedding plants. Don't compost animal products such as meat and try to avoid adding diseased plant material or fats and oils. Good examples of browns include sawdust, straw, wood chippings, shredded brown cardboard and fallen leaves. Bedding from herbivorous pets such as guinea pigs is ideal as their manure adds a bit of extra nitrogen to the mix. Compost decomposes much faster if you chop the ingredients up. So shredding woody materials and tearing up cardboard speeds up the process because there is then more surface area exposed to the microbes that decompose the compost. However, avoid shredded evergreen trees such as leylandii because they don't compost well and the pine resin can inhibit seed growth. When making compost, you want to aim for 2 to 3 times more brown materials than greens, at least initially, though some more greens can be added as the compost cooks. For most gardeners, the biggest challenge is therefore collecting enough brown materials and not just piling in loads of greens, which will result in a soggy, smelly mess. Never add lots of grass clippings in one go, as they will just form a slimy, matted layer. Air is vital to the composting process, so it's important to mix the ingredients in together and never squash them down. By turning or remixing the compost, more air is introduced, which speeds up decomposition. The 4th vital ingredient is water. If, like me, you stockpile brown materials, you'll need to water the pile to get things going when first mixing it. Build the compost pile up with layers of browns and greens, watering it where necessary to produce a moist but not soggy mixture. A good compost heap has a slightly sweet composty smell. If it smells sour or rotten, then it either has too many greens or is too wet. In either case, the remedy is to mix more brown materials in to compensate. By getting the right balance of 2 or 3 parts browns to 1 part greens with moisture and air, you're giving the microbes that decompose the materials the best conditions to work in. As they break the organic matter down, they give off heat, which in turn speeds up the decomposition. In a well-mixed heap, temperatures can easily reach over 150 degrees Fahrenheit or 65 degrees Celsius. This heap, for example, was mixed several days ago and it's already been cooking nicely, though it's starting to cool a little now. After a few more days, I will remix it to introduce more air and to bring materials from the edges into the centre. Several weeks later, the heap will cool and worms can move in to finish the process. If you follow this recipe, you should get a fine, crumbly, textured compost. Any remaining large bits can be sieved out and put into the next compost heap you build, leaving you with the very best food for your plants.
All right, let's see if we get the PowerPoint back up. All right. To go over this again, what he was saying, carbon, nitrogen, water, and oxygen. Carbon-rich materials are the energy food for your microorganisms. You can identify high carbon plant materials because they are dry, tough, or fibrous. They're tan or brown in color. Examples of dried leaves, straw, rotten hay, sawdust, shredded paper, and wood chips. I didn't put that up there, but is as well. Nitrogen, and by the way, you talked about the 8 years or whatever, on his wood chips, but if you do it this way, your wood chips break down real fast. And if you still have them in your compost, it's okay. It won't hurt anything, except maybe make your potatoes look a little funny when you harvest them. High nitrogen materials provide the protein-rich components that microorganisms require to grow and multiply. Freshly pulled weeds, fresh grass clippings, overripe fruits and vegetables, kitchen scraps, and other moist green materials are the sorts of nitrogen-rich materials you'll probably have on hand. Other high-protein organic matters include kelp, and seaweed, and of course your dried manure. Water, moisture, primarily just remember, don't get it too wet. Make it about the moisture content of a sponge that you squeeze all the water out of. It needs to be moist, just not real wet. Oxygen, now this is important because with your wood chips and your other materials that are in there, it's the spaces that you have sometimes in your soil that allows the oxygen in there. And it's very important for your favorable microbes to have these areas because they will grow more rapidly when there's more oxygen available for them. To do the work most efficiently, microorganisms require a lot of oxygen. When your pile is first assembled, there will probably be plenty of spaces between the layers of material. But as the microorganisms begin to work, they will start consuming oxygen unless you turn on in some way, aerate your compost pile. Now that's, you just take a pitchfork or, a fork and you turn it. And how often do you do this? That's where I think your thermometer comes in. You can get a compost thermometer, you can stick it down in it and find out what the temp is in there. And again, it's important that as the heat comes up in that, the microbes will kind of grow with that. If it gets too hot, they begin to shut down, and the microbes, which are called thermophilic microbes, are what's causing it to build up the temp, to break it down. And as soon as it begins to cool back down, all the other microbes come into play. There's in 1 tablespoon of soil, you have more bacteria in that than you have in cells in your body. It's a huge amount. When you look under a microscope, you can identify bacteria really quickly. Now, he had 30-to-1 ratio. Microorganisms and other soil fauna work most effective when the ratio of carbon-rich and nitrogen-rich materials in your compost pile is approximately 25-to-1, brown to green. To most people, find that 3 parts of brown to 1 part green works quite well. That's all you got to remember. Okay. Now here's a real nice key. You can also spice up your mixture. Now what that means is that you can actually make it work faster. If you add the humic type soils that we talk about, you can get Florida muck, peat moss, this type of thing. It really will speed it up. Dried manure, wood ash will speed it up. And then minerals like your C90 we talked about are in the crushed rock minerals. They've got those available now. Then of course, then the spice of life would be your good forest soil extract that we will talk about at a future time. Because I'm hoping that we get some samples that we can give you to take home and then teach you how to make your own extract, to put on your gardens, all right? Now, these are the types of composters. Now, this is the reason why I mentioned the wire out here. If any of you are interested in this, we can, get it for you. I have one of these that I have at home. The only drawback to this thing is that in turning it, it's hard to do. So what I'm doing now is building two. So I build one, build it up, and I take it off, and I will turn it, and I'll put it in the other one, and then go back and forth with that. It works because of the airspace, all the way around. You get lots of oxygen in there, and it does work fast. But it's a little harder to work with. The next type here is a trash can type. You notice they've got the holes drilled in the bottom of it, and they actually cut the bottom out. This is to allow your microbes and your local microbes to get into your compost pile and start working it. This is a little easier to work with than the wire because it's a harder side on them, and you can turn it relatively easy. Oops. This one, a little more elaborate if you want to go get some concrete blocks or whatever and build one of those. You could do that again. You notice how they have the spaces open so that the air can get in there. This is my favorite right here. Is to build either one with an open front or just build a box. Keeping, again, your spaces between your boards on the side to allow air in there. This is easy to work with. You can put a tarp over it if you need to as well. Again, building up the heat will help to expedite the breakdown process of all your organic materials in there. Those are the four types that there are others. You can either build a trench. Years ago, my grandmother, what she would do is she'd go out and just dig a trench in the ground, start throwing the stuff in there, and she'd throw a tarp over it, and then periodically she'd go in there and she'd just turn it, and she'd add her molasses too. That's the other thing. I never knew why. Now I do. It feeds the bacteria. All right. Now it's talking about use of wood chip. Now the pH thing this is the last I want of the slide here. And then we want to get started on these soils because it's going to take a while to get these studied real quick. This really helps to improve the fertility of your soil that you're working with. And that's to maintain this pH. 6.5 to 6.8. As I said before, if your pH gets too high, or if your pH gets too low means it's acid, too high means it's alkaline, then you have an offset. Plants don't grow well, and neither do microbes. The good microbes begin to die. Your soil actually then turns into more, instead of, you know what anaerobic and aerobic means? Aerobic is oxygen. Anaerobic, no oxygen. It becomes anaerobic, and when it does, then that's when all the nasties start growing in it. And you start growing weeds again. As long as you keep that pH in that range. Now, when you test your soil, now by the way, I have 4 pH meters up there. That first meter that you see here on the left, there it is. This one here. These 2 probes, you have actually a triple effect. I mean, this one will do 3 things. It checks the moisture, the light, and the pH. This one is just a pH meter. This one is a simple little tube that you take, you put it in there. It's got a material you put in it to test it to see what your pH in it. This thing costs about $12. This one, even though it's just 1 meter, it costs about $14. This is about $4 or $5. This one is about $70. It's a more professional one. So you can get these on Amazon. You can go to Lowe's has them. I found out, and so does Walmart. They carry it. Not all Walmarts, but you might want to call and see if they've got one. pH is important. So what are the things you need to remember with your soil or your compost that you're making, and your soil too? Again, is what? Carbon, nitrogen, moisture, pH, and oxygen, right? Those are the things you got to consider when you're building a good compost to build up your soil. Now, let's talk about that just a minute. Let's say that you want to do solarization on your soil, on your property, on your garden, and you leave it on there to kill everything and the weeds and everything, and you take it off and it's ready to go. But like you're saying, most of the biology of it is gone as well, good and bad, but it does kill the bad microbes. But what you will do then is take your compost that you have developed. It will start having good microbes in it. And by the way, someone asked the other day, should they put earthworms in compost as it's developing? What's the answer? No. Why? Because they kill them. Temp when it goes up. That's when it begins to cool down. That's when, in fact, if you've got any earthworms around, they're going to come there anyway. But you can add earthworms to it. Now, we do have a couple of people here. They're not here today, but they want to develop a worm garden themselves. They're going to start worm beds. They're going to grow, I think they told me, Alabama jumpers and redworms. The red wigglers, they call them. These are the best ones for Florida. And that way, when you get your compost, your garden ready to go, you just go ahead and seed it with these earthworms. They'll stay if your soil is right, and you really do need them. Most of us, when we got our property or we've been using our weed killers and our fertilizers and everything you can imagine on the soil, they're gone. The earthworms are gone. They've left. Some instances you find them coming back. You need to expedite that because earthworms are very, very vital for the whole operation here. But once you get your soil prepared and you add your compost material in there, never, ever till your soil. You know why?
Well, it seems to be going against what you were telling about stirring the stuff up so it gets oxygen in it. So if you never ever stir it, how do you get oxygen?
You never till your soil. Why don't you till your soil? You actually destroy the microorganisms and the symbiotic relationship it's got with the plants. Pull your plants out, but don't plow it up. Don't do that. I mean, if you got weeds growing, do your solarization again. Keep that, first you're going to test your soil. You'll notice that when he was using the wood chips, all right? Now the same is true with anything that you put on your soil. You mentioned mushroom compost or any kind of compost you're putting on there. As you're doing it, your soil builds down. Now, when he first showed the film there, he had sand, nothing growing up but weeds and very few weeds. It was because it was compacted. And your soil will probably be compacted. But if you go in there and you start tilling it, you're going to have that compact layer come higher. And all that sets up is an anaerobic situation for your soil. Let it do its job, because your microbes, all your organisms there will help to develop, and they do their own plowing for you. And they do all of that. But if you put your right compost on there, it's going, and your microbes will set up this oxygen forming these different types of bacteria. There are something they've estimated over 14,000 different bacteria in your soil. They have not identified all of them either. I think that the most they've identified is like 1,200 bacteria in soil. That's that many. So they do different jobs, and some of their jobs is to do that, to oxygenate, to break down that hard pan that you have in your soil. You go plowing on it, you go driving over it with a tractor, you're going to just do nothing but compact it again, and you can create your problem again. That's what they're saying.
What about the man's pathways that he was 8 years walking on?
Well, what did he have on it though? What was he walking on?
Wood chips.
Wood chips. They were doing their job all the time. You weren't driving a tractor over or anything like that, or trying to till it. All right? Any questions?
We always thought when you till the soil, it was helping the roots of the plant to penetrate the soil. That's how we used to think.
Right. Well, I mean, on the farm we had 3 tractors and big plows. And we plowed up all our property, you know. I can remember now we had a hard pan, we call it. It was a compacted layer underneath it. And we had big plows and we had this big rake-like, can't remember the name of it now, but we used to go down in and we'd go down sometimes 3 feet and start tearing it up again, you know, in order to.
Subsoiler.
Yeah. Right.
What about the composting that gets laden with worms breaking down this stuff? Is that a bad or
What?
worms?
In the compost.
Yeah. Like if you had it in a bucket or something and worms.
Well, if the compost has gone through its process to develop, it's gonna bring worms anyway, if you've got worms on your property. Is that what you mean?
Yeah, they're just
Oh, no,
not the big worms, the little ones.
Maggots.
maggots?
Yeah.
Well, then you've got
Not a good compost.
you're not good compost. Now, that's more anaerobic there, because it won't, maggots won't come around a good compost pile, because the heat and everything will kill them anyway. What you probably need to do there is if you've got it in your compost pile, is move it out, you know, get enough oxygen in there and start adding more brown to it, because you got too much green in there. And you probably added too much fruit.
Everything.
But you gotta make sure you equalize it out, the brown, you know, to your green, all right? Okay, another question?
Yeah, Doctor, in preparing the soil initially, sometimes you find the area is grown a lot of weeds, a lot of crabgrass and stuff like that. And it's necessary to dig down, and you're in effect tilling the soil in that particular area to pull out all of these weeds and crabgrass.
If you take and do solarization on it, it'll kill those, most of them. And it may take more than one try. It may take a longer period of time, but it will kill them that way. Because I tell you, all you're doing when you're tilling your soil, and if you think you're going to kill crabgrass or you're going to kill Johnson grass with the rhizomes, you're not. They're there. They're going to come back. So you've got to do something to kill them anyway. That's the reason why Monsanto is getting rich.
Okay, but these are big clumps of grass and weeds, you know.
Yeah. But if you build your temp up above it, it'll kill that stuff. All right? Now you're talking about moving it to plant stuff in, right?
Yeah, well, I'm thinking, you know, like with the autumn coming up, we prepare the soil for, let's say, planting in spring or whatever. You know, now it's the time to prepare that and getting rid of the weeds. And I'm thinking pulling up some of these weeds by hand.
Well, try the plastic. See what happens.
Okay.
So you're talking about that in your flower bed?
Sure, anywhere. You know, and I mean, you can build your soil back up. You still got organics in it. You know, but your microbes will be gone. But you hope all the weed seeds are gone too when you do that.
You do plow it, you just don't have to reestablish the biology.
Yeah.
Once you do, the weeds are going to go away anyway. Once you've established, you know, the good organic aerobic state of your soil, weeds are going to go away anyway. I mean, they will grow some, and then you probably have to pull some. I mean, we're Florida here, and birds flying around with seeds all the time, so they're going to transplant it for you if you don't believe it. But you're right, you're building the good biology back up in the soil for that. If you go into the forest, who does the weeding there? You ever noticed a lot of weeds in the forest? No? If you cut the trees down, they'll start back because again, the symbiotic relationship that it has goes away. But as long as you have the good biology growing there, you're going to have less problems, not only with weeds, but your nasty pathogenic organisms, your vegetables, your fruits, or whatever you're growing on it, your berries are going to be richer and more disease resistant as well. That's the reason why I urge you to use, a good mineral complex, whether it's C90 or any of the others that's on the market, in your soil or in your compost, because that will help with the minerals in there that build all the genetic pathways of your plant. These are the protective pathways of the plant, but it also builds the genetic pathways for developing higher levels of phytochemicals. These are nutritive chemicals that we need in our bodies that a lot of the fruits and the vegetables don't have. That's the reason why we're doing it this way, to get their biology back right in the soil to do these things. So what we're going to do is we're going to go through now some of these soils here that we have, and we try to get through it as quickly as we can. You can help me with your soil. We're doing this, and just see what you got in your soil. All right. Now, this is my old microscope. I'm getting another one. The new microscope is going to have not only a camera on it, but a video thing, so I can hook it up to a computer, and you can look at your own soil as we're doing it. That'll be about 3 months when I get that one, okay? That'll be fun. Then we can see what's happening with your soil. Same areas that you dug your soil up, or you want into this soil, you're going to plan on it or going to start building it up. We like to see what's happening with this ongoing with your program. If we didn't have this, we'd still do it, but it's just fun to look and see what you got. Right? All right. Any other questions? All right. Let's get started with this. All right, Jeff, I'm going to go ahead and finish up with yours. All right?